Okay, we're working on number 10. It's asking us to do all the same things. If you look at this, 2 cosine 3 theta, that's going to be a rose with 3 petals. Rose with 3 petals. It's cosine, and we can see immediately that symmetry would be the polar axis. If I just put a negative theta in for theta, I still get the same equation. So I can add this polar axis in here, right here. Okay. I know I'm going to have a rose with 3 petals, and it's symmetric to the polar axis. Now, how big are these petals going to be? I'm going for my maximum R values now. Absolute value of R, I would make, it's going to be 2 cosine of 1, a negative 1 to get the negative value, and that's the absolute value of negative 2. And then the absolute value of R with a positive 1 gets you a positive 2. So I'm going to have positive 2's and negative 2's. So I find theta. If I use a positive 2, I get cosine 3 theta equals 1. And if I use a negative 2, I get cosine 3 theta is negative 1. So I'm looking for plus or minus 1. Where is 3 theta plus or minus 1? Well, where is cosine plus or minus 1? That gives you 3 theta. So it's plus or minus 1 at 0 and pi. But because it's 3 theta, I have to do 3 theta times 2 pi to get how far out I go. So I have to go all the way to 6 pi. So I go 0, pi, and then it would be 2 pi, and then 3 pi, 4 pi, 5 pi. You don't really need 6 pi because you get up to it. So now that would be dividing each one by 3. So 0, because you go from 3 theta to theta, you divide by 3. 0, and then pi becomes pi over 3, 2 pi becomes 2 pi over 3, 3 pi over 3 becomes pi, 4 pi becomes 4 pi over 3, 5 pi over 3, and you don't really need this one because you have 0. So you know you have all those places where it equals the maximum value 2. So you have 1, 2, 3, 4, 5, 6 places, but some of these might repeat on top of each other. Okay, let's find out where our zeros are. Set R equal to 0, and I get cosine equals 0 at pi over 2, 3 pi over 2, and then keep going. You've got to go all the way, 5 pi over 2 to 7 pi over 2, and then dividing each one of those by 3, you get pi over 6, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. So you have quite a few zeros too. Again, those probably repeat. Now the symmetry is the polar axis, so I only have to do these points on this side. So I'm going to work from 0 to pi. So here we go. The first one, 0, is 2. That's one of my maximum values. So put in a green dot right there at 0, 2. And that's on the polar axis, so no symmetry I can use there. I'm petals, so I'm going to 12. At pi over 12, it's about 1.4. So I have a point here, and that also means symmetry. I would have a point across the polar axis underneath it. So, and then at pi over 6, it's one of my zeros, so I see my first petal. There's my first petal. All right, so I was up to pi over 6, and now I'm going to go to pi over 4. And at pi over 4, it's negative 1.4. So there I have negative 1.4 right here. Okay, and across the axis, it would be all the way up here. Okay, so there's my 2 points there. Next, at pi over 3, I have negative 2, so I go backwards, and it's one of my maximum values. Okay, and its symmetry across would be at 2 pi over 3. And then at 5 pi over 12, I'm at negative. This is my 5 pi over 12. I'm at negative 1.4 again, so I'm here. And its symmetry would be up here. And then at pi over 2, I'm down at 0. So I know I have 2 more petals, that petal and that petal. Now, if I go to 7 pi over 12, look what happens. This is 7 pi over 12 right here. Okay, I'm continuing on. I'm repeating because that is 1.4, so that's getting you this petal, and it would be reflected across that petal. So you're done. That is your rose with 3 petals.